What's going on, guys? Thanks for joining another lesson with Everything EE. Today, we're going to be talking about combining parallel resistance. In the last video, we talked about combining series resistance. So this is the next step that you'll be challenged with, and it's going to be combining a parallel resistance. So let's take a look. And in the last video, just wanted to mention this. We're talking about voltage source. Don't let that trip you up too much. At the beginning, a lot of professors won't even put the voltage source, um, since the main thing is to focus on understanding how to combine these parallel and series resistance. So here we go. We got two resistors, R1 and R2. We notice here that they're connected together on one end and connected together on another end. This is just showing that these are in parallel, right? They are parallel to each other. They both share a node on each side. So what we're looking for is the equivalent or total resistance of these two resistors in parallel. RT, or R total, is equal to R1 in parallel. That's the symbol for parallel. Parallel with R2. Okay? So the method here is going to be RT is equal to, and this is valid for any number of resistors, okay? 1 over R1 plus 1 over R2 plus however many resistors you have, right? Plus 1 over Rn, n being the number of resistors you have. All right? So let's take this step by step. Let's get rid of this and just focus on the two resistors that we're working with. Let's go ahead and just say this is 100 ohms and this is 25 ohms. Why not? All right. So let's plug in here. 1 over 100 plus 1 over 25. Keep the math going. It's going to be 5 over 100. Just got the common denominator here. That's going to be equal to 100 over 4, right? So 4 over 100 plus 1 over 100 is 5 over 100. Since we have a fraction under here, we technically have 1 over 1 here, you can flip the bottom fraction, and that gives you 100 over 5, which is 20 ohms. Alright, so that's our answer. RT is 20 ohms. There is a trick, and I'll show you the math. There is a trick here for two resistors. Let's go ahead and take this and do some math on here. We've got, if we found a common denominator for R1, R2, we would have, for the first one, R2 over R1, R2. So here we just multiply R2 on the top, R2 on the bottom. And then here we're going to do R1 on the top, R1 on the bottom. It's going to give us R1 over R1, R2. Bring it over here and combine. We have R1 plus R2 over R1, R2. Right, and same idea as this right here. We have a 1 over 1. So we can flip this, right? And if you guys aren't clear with what's going on here, you have 1 over 1 divided by another fraction. You can just get this denominator into the top by flipping the two. So you're going to end up with R1, R2, R1 plus R2. So let's check, right? If we plug in these numbers, this is an equation you can memorize for your tests or for your assignments. If you have two resistors in parallel, you can kind of shortcut with this equation, right? And so this was the long way up here, using the 1 over R1 plus 1 over R2, and this is the shortcut for that. So we should get the same answer here. So let's check. We were using, for R1 it was 100 and R2 is 25. So R1 is 100, R2 is 25 over 100 plus 25. Let's get some space here, right? Let me bring this over here. $125 over 2,500. So that's going to give us 2,500 divided by 125 gives us 20. So you can see here that these two answers match. This is a shortcut here. So you guys can use this, memorize it. That's the equation for finding the equivalent resistance for two resistors in parallel. It doesn't really work when you start expanding out. I guess it could, but it just gets really big and messy. You might as well just do it the old-fashioned way, the harder way. So thanks guys for checking out this video. Post in the comments below any questions you might have, any other problems that you might want to work on. Just let us know and we'll take a look. As always, thanks for watching, and please like and subscribe. Thank you.